Hello, I'm Shadow of Shadow Gaming, bringing you Programming with Shadow, episode number 35. In today's video, we are going to continue our discussion on unit testing, our registration simulation. So, as a recap, a unit test is the way to be able to run section or part or run some of your code and run it consistently, and you can do some setup. You can run what you're testing, and then do some assertion to say, I expected this. Is this what I got out of it? Using a test, we can get it, or we can use it so that we can do it repeatedly, and hopefully without too much randomness. Like this test here is actually going or very dependent random. If I turn it down the number of tries, it'll fail a whole lot of the time, but up real high, it's not as bad. So that's sort of what we're talking about, though. See there, we test failed, and it's failed because it was out of range. See where I was doing it. It's out of range, but if we bump that up real high, the average gets, I think it's 100,000. If we bump that up real high, the average will keep that from happening. Now it might occasionally fail, but it's not likely, and we're sort of testing the distribution. That's just a very first test we wrote. We were using XUnit as our testing library, and it's one of the three common ones I think I've heard of. I think there might be more than just the three. Like I think I've also seen a T unit, but I've never actually seen it anywhere. So there might be others. So when I was going through this, I didn't put a lot more thought into testing these two. We might come back to these, but for now, we wrote tests for this, but I don't, or I'm going to go on. We might come back. So other classes. So some stuff wants you to try to go high on testing. Some stuff doesn't. It depends on a little bit of what if you're working somewhere. They might have some rules, like you might have to have so much coverage. Sometimes they don't care. In cases they don't care, this is a good class. For example, it doesn't do anything. I'm returning a string with these values. I'm setting these values in the construction. I would say there's a very good chance that this there's nothing here that's going to fail in this class. And if it does, it's something C#. So until I put some more logic in here, I wouldn't worry about this class. I think it's the same thing for registrant. It has some default values. Like maybe you could check those default values if you really wanted to. In general, though, I'm going to say that there's not enough logic here to really worry about and move on. Event type, so enum, it has no logic, so another one. That brings us to menu items, also an enum, nothing there. Menu convention registration. It's also program. Check it program too, but let's start here. So the very first thing is that public methods are the ones that you can test. So if I try to access some of these private or other ones, I'm not going to actually be able to read. So let's take a look. So we'll come over here to my Solution Explorer. And under Simulation, I will add a new test, add a new class, and we will call this class Convention Registration Tests. There we go. Now we've got us a second test file. Public. So that probably doesn't matter there, actually. So let's go ahead and start a fact. Like I said, we'll come back to the name. Test is not a good name, but let's see what we're testing. So we have, there's a little bit of logic there. Let's start there. Let's test a property first. So property, there's not a lot to it. It's basically a method. So I'm going to kick this over to the I'm going to right click on this, and then I'm going to new vertical. We're going to close this. Never seen that before, so you can scroll on the taskbar if you have too many tabs. I'm going to leave it like that so they're all visible, but might adjust that. So let's go to the name first. So longest queue sets a new value when it is longer than the current longest. There you go, something like that. That begs the question, what is current longest default? And it is 0. Okay. So let's add another one here. So we'll copy this, we'll add that. The longest queue defaults to a length of 0. We'll do, so I'm going to do convention registration. So picking the second one. The first one's the test class here. We don't want that. And I'm going to use a different name here. So normally normally I've tried to pick decent names. I'm not good at names, but try to pick at least decent names for it. This time I'm just going to use this SUT. And I'm going to say new. So SUT, that stands for System Under Test. And I've actually seen that in a couple, or in at least two or three different spots for using the name of the test. So maybe it's more conventional than I would have thought originally. But what you can do with that is you can really what you can do with that is it's just a holder for the value of the test. So it's saying this is what we're testing. It's a convention register. And all we're going to do is we're going to say assert dot equal 0 dot longest queue. And you might ask, is there any value to that test? Not really. It has the same problem as before, but I'm going to say that it has a little bit of value because maybe we had some reason to start at 0 instead of having a major negative number. But I'm going to say 0 is the business logic reason because that's the starting place of a empty queue. And that also indicates that maybe our queue there should be unsigned. The longest queue, maybe that should be an unsigned int rather than any. Let's just switch that just to see what happens there. Uint. And it could probably be a U short because I would doubt you're going to have one that's having or 65,000, but we'll leave it there for a second. Let's see what happens. What I pressed there, by the way, you go to your code, you can do right click and you can see go to definition, and it is F12. It's also a peak definition. I've occasionally used that, but usually I'm fine to do go to definition. So F12. So if I press that, I'll try to remember to say F12 for a little bit here. Make this uint. It's the uint. There's the question if that's valid or not, though. It can't be negative. I don't think it can. Count size. Yeah, I'm actually not sure. Hey, let me actually Google that in the back. I think it can't be, so maybe this is actually good. Okay, so yes, so if you're in a multi-threaded area, yeah, you could actually get a negative count. It makes sense why allow it, but yeah, I think we should be good here. So the other thing is that we should be, since we're seeing or so when I say multi-threaded, that means you're running multiple parts of code at the same time, and they can be updating the same thing. And what you could do there is then you could remove the same item twice and get a negative value, something like that. Since we're not doing that though, we're in control, so we shouldn't. So this should be fine. So cast should be safe because we control adding, removing from the windows. So we might should check we actually do manage that. So what we could do here is we could right click again and we could find usages. Or maybe that's not what's called here. References. Yeah. And here we can see where it's actually used. Here we create it. Here we add. We care about removes. Here's a deck. Here's a decu. Window index here. If we go down here, oh, it's less than count. So yeah, so we are doing it here. So okay, so we are checking. Good. Try that again. See the other references. There's a peak. Peak doesn't do it. So yeah, we only have that one use. So yeah, I'm gonna say we're good on that, and we'll leave it there. All right. So back up here to where we were started though. So what I did was change this to uint, and maybe that makes more sense for what we're doing here anyway. So here we got to add a u though. So that adding a u makes that an unsigned 0 instead of a signed 0. But for our purposes, it should be fine. And we should see that this test also runs green again because that's still the default. Oh, what that error is. So I can tell there's an error down here by looking down here at the little red display summary. Value. We'll make this indeterminate type there. There we go. So here it's the type of uint. Now down here it's the type of int. There we go. So we made this method generic and we're able to pass it through. Now if we try to rebuild, when I clicked that run test, it tried to rebuild and could tell it couldn't do that. So now if I run the test, we will see green. So that test took forever to run, 200 milliseconds. Now it's just 4 again. What we would see there is if we come down here and run it until failure, you should see it. That's staying pretty consistent actually. I was gonna say you probably will see it go down, but maybe not. We'll stop that and move on to the second test. So second test here. One other thing I should mention, this looks like a long name, and it is. I find that it reads nice down here though. Longest queue sets a new value when it is. Let's switch that when the value is longer than the current longest value. Even though that's a long name, I find that it usually reads pretty good in the list here, and actually it's being cut off. Maybe it doesn't. It usually does. And I've zoomed in so everything's odd. Or I guess I've made text bigger. Let's do the same thing though. Let's create one of these. So let's see. So our operation here is, I guess let's add these. We're asserting, not asserting, arranging, act, assert, just to keep them in place. So here's one. This one's a little different. So here we have arrange, act, and assert. So what we could do there, if we didn't want to do that, we could get could do something var length equals longest queue, and then we could use length in here instead, and that'll keep us in the path. Then act is separate. So we could do that as well. I'd probably not do that. I'd do it the other way, and I wouldn't add the comments. But while we're learning, we'll go ahead and leave those in for now, so we can keep track of the steps. So for the second one here, so we arrange, we create. Another step of arrangement is to set up the situation. So in this case, we'll do the longest queue equals, we'll say 42. We need to say 40. We might not need to say the U actually, since it knows it's U. Yeah. So now down here in act, we'll do the same thing. We'll say var longest length equals the longest. And see, now it's showing a questionable if this is actually a good test, because now it looks like we're just setting a value and doing it. In reality, we have a little bit of logic here, but not a lot. So here we can say assert equals 42 and longest length 42u. That will pass. So now we've got a problem though. We've got a number here. So what I'm going to do is up here in the range, I'm going to do const uint expected length equals 42. So we've got magic numbers again. So these are just numbers here that don't really have a meaning. I'm using these as the test value, but what we're going to do is just set those. There's just a test. Orange, green, good. Now I'm going to copy this once more. So let's write another test. Does not set a value when the new value is shorter than the current longest value. There we go. So now we set this, we set its expected length. So Q is 42. Now so dot longest Q equals, let's just set it down a level, -1. Let's do something smaller. Let's say it's 5 now. Const uint new length equals 5. And I would probably leave that one because it's not used anywhere else. As soon as it was used another place, maybe, but the test is pretty short. It may not matter. Here, what we should see is is if I come down here and run. Notice my little run button's not showing up. I don't know why that is. Still not showing. But the test ran either way. Interesting. I don't know why that's not showing. But yeah. So if we look at the test here, does not set a value. Ran in less than a millisecond too. That's pretty good. Object initialization. All this is wanting us to do is do a little bit of cleanup here, but I'm not going to do the cleanup. What I'm going to do is put it in initialization. Maybe that's cleaner. I actually don't like it in this case. I actually like specifically saying what we're creating, so we'll leave it as is for now. Because that would be my file. I'd have the constants in their own section. I'd probably leave that one. There's just a couple tests here, and now if we look, there's 3 tests here. And if you have somewhere that requires code coverage, you'll notice that all these are now covered. I don't have any code coverage set up on this. That was that ReSharper plugin I got rid of. That was one of the things I use it for. Let's start looking at another method, and this one's big. Let's see if they don't have a easier one. Private. We do not. Okay. So let's start run. So run's way too big to test. There's so many things it does right now. Like it runs everything. It literally runs everything. So what we could do is write a test that goes through and checks at least some of the cases. So validate input. So let's remind ourselves what it does. So it goes through and checks different values here. So this could be a good one to see if we get the message we expect. So yeah, let's try that. So back. So fact public void run simulation throws when let's see. And registrants is less than 1. Maybe there might be a decent name test. Unfortunately, that shows you what we're going to next couple ones are going to be. So what we could do to test this though is we could say arrange act assert. We could do the same thing up here. Grab this. Now for the act though, we'll do run simulation. Alright, so what we're gonna have to do here though is right now we're gonna run that and it'll throw an exception. We need to be able to catch that exception. Turns out exceptions are just objects as well. So what we can do is so XUnit already has a method for that, so we can do assert dot, there we go, throws, then you put the type of exception. We're currently using exception, so we may need to change that. Now we're going to do something we haven't seen before, I don't think. I might have showed this. It's called a lambda expression. So we're going to start parentheses and we're going to say this and insert run simulation. The prediction there's got it right. It's terrible to type. So there we go. So this is saying assert this throws, and lambda says I have a method, and when you run it, it's going to call this method. It's going to say that simulation. Run simulation. So what we can then do is we can say exception ex equals that. And I would probably just say var in this case because we can tell it's an exception, but we can do that. Then here, you can say assert equals this ex.message. And there we can check what message we're actually at. If I can pick the right one. So one thing here is we have the assert here and the act here. Maybe instead, let's do it like this. I think we can do this. I think we can do it like, yeah. There we go. So now our action is the method we are running. I wonder if we could do a function here actually. No. Lambda. Another lambda. Lambda. So yeah, everything uses lambda, so maybe we should just stick with that. We'll stick with the lambda then. So their act and assert are going to be from the same method then. So all the action was doing is it's just another way of, like we were using function to pass methods, or the func keyword. You can also use the action there, and we're also using the lambda here, and apparently lambda's common. So this is going to fail, and what we need to do is we need to say expected number of registrants, and the expected number is 0, and I bet we say should be more, is invalid. Is invalid. It should be greater than 0. Please re-enter. So there. And this is still going to fail, but let's run it and show why it fails. There you go. Failed. Hard to read. I'm going to make it just a little bigger. There. Exception type was not an exact match. So it threw an IO exception. Handle is. Wait a minute. That is not the error that I should have got. Did it throw? 97 on display. So it made it all the way through, so we must have some kind of sane default. Yeah, we have a default, so let's set that. So up here in the act, we need to do soot dot let's see, what were we checking? I've already forgot. Expected number equals 0. And now we'll do it. So what failed there is it was able to go through the defaults and then failed. This one now fails. No exception was thrown, so what happened? So let's put a breakpoint here. So I can click over here, or I can click on it and press F9. Now if we debug, let's see what happens. Do we get here? We do. Oh, I'm out of my memory window. Expected number is less than 0, so we get a message here. Error message. Everything else should be good. Oh, it is not. Expected duration is not valid at default. pause. All right, trying to resume. Let's see how it went. What I just if it looks like nothing, what I did was pause the recording. I had to step out just a second. All right, so back here though. So here we got us a second message. Expected duration is greater than or equal to we error. So there we found our first bug. What that's going to do is it's going to add it to their message here. And here's our second bug. So we're not outputting any of our error message. So we found us 2 bugs already. So that's the purpose of unit testing. So first thing here, that is a bug. So if it is null or white space, we should stop there. And that would have caught the other one. So the other one here is this should be, if it is less than that. Less than that. Now we've actually found 2 bugs. Let's see if it actually runs this time. I think it will, but I think it'll still fail. Still fails. So strings differ, and what the strings differ on is the new line T. So we could handle that a couple ways. What I might do is this. Let's see. Insert matches /s, I think. Let's see. I thought it was /s. Plus. Regex anymore apparently. Let's not do that. We'll just do it. We'll just do it fully for now. We'll adjust that later. Well, we know what it is, so we can just say /n/t. That will work. I feel like I want to do the other one, but what I was going to try to say was just some white space at the front. And there, now we've got a green test. So now we have a test that says, okay, if the registrance is 0, it doesn't do it. So what I'm about to do is not a good test, but we could try another value here as well. So let's do a change this fact to something called a theory. So the theory is a way to let you pass in information into a test. So I can say here inline data. I'll say 0, and then inline data. We'll do -1, and we'll do 1 more. Maybe 1 more. Let's say int min value. That may not work. Oh yeah. Okay, so we're passing it in, so we have to give it something to pass it. We'll say int number of registrants. Now we will use that here. There we go. And there we got rid of our magic number too, so that's even better. One thing we do need to do here though is we need to say this. $. There we go. We'll say it like that. Let's see if this works. Now we tested a couple of values. And all 3 work, and they show down here like this, so we can see there's 3 values here, and values are, due to the length of the test, hard to see. You can see them down here. There's a way you can do multiple values in a test. There's other ways to do it as well, but this one's easy and good starting point. So what you do is you change the fact to a theory, you give it some data, you set up the parameters, and you can have multiple. There's comma separated, so if you need more, you would add a comma. Then you just use them where you need to use. And maybe that's not a good use of it, but that is at least a use. So let's see. We can do the other ones here too. Let's just do a couple tests, but we may not do many of these because these are more of we're writing them, but they have a little value. Like we already found 2 bugs with them, but maybe there's not a lot of value. Now let's turn that back to theory. So theory, so we'll do hours of operation. Inline data is 0. So it's less than 0, so -1. Copy 25, 4. 0 is invalid. -1. 5. We'll do this to min value. And we'll do a max. We'll throw in a max value while we're here. So what I'm doing here is called it's called boundary value analysis. So my boundary here is less than 0 or greater than 24. And that's all we're doing, or that's all we're doing. We're testing around the boundaries. So these 2 will fail. So probably intentionally. So yeah, we probably don't even need these 2. So comment these 2 out, or delete them, I guess. So now it's saying that there's already one of the same type, so we need to adjust that. When hours of operation is less than 0 or greater than 24. We'll change this here. F2 is rename. There we go. And this will fail because the message is different. We'll run it here just to see it fail. There it fails. So the test should be sort of valid. And now we'll just adjust the name. So hours of operation are invalid. They should be. There is a discrepancy. That's what I figured from how I would have wrote this. So there is, that's the second bug. So let's add the values back here. So another one of our business rules here is that they should be between 1 and 24. It may be that that one's wrong. Maybe that one's the bug case, but I'm going to say it's the other one because that gives us a case here. So now if we run this, it's going to fail. But only 2 of the tests should fail. They all failed. Argument out of range. It got through it. Why did it get through it? They all fell for the same reason. Operation. Alright, so now I expect to see 2 of them failed. Yeah. This one failed because of that check. So what this was supposed to have been was less than 1, greater than 23. Now if we run that, those two, we're saying that it can't be an entire day and it can't be less than an hour. And then those pass. There's just a third bug. Unit testing is already paying off. Number of windows, so we can do this again. And this is going to be closer to the first one, so I'm going to grab the first one again. I'm going to do the boundary analysis again, so 0, -1, and a minimum value. Rows when expected, number when number of windows. So F2. The number of registration lines is invalid. It should be greater than 0. Please re-enter. There. Now this test should run green, I believe, unless I've typoed again. Right, so it's a lot of typos. So, oh, didn't actually change it. Now we did a error. So let's see what happened. Line 84. Made it down all the way through so it didn't grow. So we did find another bug. This one's less of a bug though. So what we've done here is we've got entered periods on the last, but not the last. So there's just another bug. Now we've got an error. So it's saying it didn't throw out 0. Less than 0 should be less than 1. So there's just a fifth bug. Always fun when you're finding bugs. There we go. There's just 5 bugs. So we have one more. So let's go ahead and do it. It's going to be the same thing. We'll grab this. What? Grab this. Paste. Rows when expected registration duration is less than F2 expected registration duration. There we go. Now if we run this test, let's see if we get a green run this time. And so let's see. There's just a, oh, we didn't finish the message. Expected service time is invalid. Should be greater than it. Oh. Should be 1 minute or greater. Please read it. Now let's see if we did. Still got a typo. There we go. All right. So that one I'm not going to count because that was just me trying to hurry because we're out of time. But there we go. We caught 5 or 6 bugs here. And I'd like to say that all of them were planned. At least 2 of them were planned. I actually did put this at 0 intentionally, but yesterday, other day, and this one I had it flipped. I'll say the other 2 weren't planned. So half and half. So 3 were unplanned, 2 were planned. So, So So what I wanted to show from this though was the theory, and I'm doing some more testing. There's just a little bit. So one other thing, validate inputs. So these are the main some of the main logic of their inputs. So this could be a good place to actually break these out into some kind of class, like maybe I don't know, some kind of class that contain the inputs and have all the logic in there to check them there. So if we want to do some refactoring, what we could do is something to that effect. Then it could handle all sides. Like we could have a class. I'll think about it. What I'm thinking is we could have a class here that does some of this stuff, like maybe a window class that does its own validation. Then you have to. I'll think about refactoring this a little bit more. This may be all right, may not be. So we'll go ahead and break on this point here because we're at time. So in the day's lesson, we've went a little further. We've added some more tests. I'm going to control dot these guys out of existence. We've added some more tests following our act range assert, and we didn't always follow it. Sometimes we combine the two. We tried to follow it. So now we have two ways to run a test. We have a fact and we have a theory. So a fact is it's a statement basically. So it says your test here, and it takes no input. So it's whatever the test does is done inside the test. It's one unit. Theory, on the other hand, lets you pass input into the test. So you have a theory that if you apply some numbers to it, something changes. So we're using that to be able to pass inputs in and check that the inputs pass through. In doing so, we were able to test our business logic. So this would be the logic that our application is expected to run with. Like, there's no computer reason that we can't accept negative 2 billion or positive 2 billion. No reason we can't accept those hours of operations. They don't make sense for hours though, and maybe using an integer here for hours doesn't make a lot of sense. But we'll think about those questions, and who knows, maybe there might be some refactoring here in the next lesson. But there's just some usages of theory, passing in values, and writing some more. And again, these look like long tests. I would argue that I actually like the length a little bit. And I like doing this style where I say the method I'm testing, what action it does, throws, sets a value, doesn't set a value, defaults, and then when or why or what's not when or why is the two I usually do. I find that to be readable, especially like if you're in a CI/CD environment. So CI/CD is the continuous integration, continuous development. So what you're doing there is you're sending it off to a server basically and letting it run through the tests and make sure your code's good. And you're doing that through the whole team. And I found that the longer named ones like this, like you can still get too long. I would argue that these are all right, but it tells you a lot about the test without having to actually look into the test, and you can sometimes use that when you're reviewing code, or it can be useful sometimes. Sometimes there's reasons to not have it that long, like maybe you don't like having the name there. I personally do, but maybe we could break these out more and have better names. And we might try, like I said, we might try to do a little more refactoring here in the next lesson. So we'll go ahead and stop there. So thanks for watching and have a wonderful day.